Alright, this is section 11.5, day 2.
Let's go.
We're going to continue talking about what we started talking about on Friday, except now we're going to look at actually interpreting some of the data that we're taking from our data sets. So the first thing that we're going to talk about now is finding the range of our data set. And the way that we find the range is by taking our largest number and subtracting the smallest number. That'll give us the range of our entire set, or our entire data set. On Friday, we found that we could separate our information or our data into 4 parts, and we called those quartiles. Remember, we found the first, the second, and the third quartiles. We're going to use those quartiles to find what's called the interquartile range, or the IQR value. And what that is the difference, or the distance between the third and first quartile. So if it's the distance between our third and first quartile, it's also the length of the box in our box and whisker plot. So in example 1, we're going to find our 5-number summary that we found on Friday, and then we're also going to find the IQR value. So we're given this set, and remember, anytime that we're dealing with a certain set, you need to make sure that you put it in increasing order. So you start with your smallest number and you go to your largest. So we have to reorder our set that we're given here. Our smallest number that we're given is a 3. Then we have a 4, a 5, a 6, a 7, 8, 9, 10, 11, 12, and a 19. So that should be all of our numbers ordered like that. So now to find our 5-number summary. What's our minimum value now? What's our smallest value in our data set?
You just write it in order, right?
3.
Yep.
3, 19.
So our smallest value is 3. What's our maximum value? Is 19. Now for our Q values, or our quartiles, remember that Q1 is after we found our median of the entire set, we're looking at the left-hand side. So I like to make a little note, this is the left median. Q2 is just our regular median of our entire set. So I usually just put entire, so that I know that that's the median of the entire set. And then Q3, after we found the median of our entire set, we're looking at the right-hand side for Q3. So Q3 is right median. And I just use those as a reminder to remember which one I'm looking at. So we're going to want to find Q2 first, so then we know where our sides are for Q1 and Q3. So we need to find the middle value, and our middle value is 8. We have 5 numbers on the left-hand side and 5 numbers on the right-hand side. So 8 is our middle value of our entire set. So for our Q1 value, we're looking at the left-hand side. So we're looking at 3, 4, 5, 6, and 7 is our left-hand side, and now we have to find the median of that set. So the middle of that set is 5. We have 2 on that on the left-hand side, 2 on the right-hand side. So our Q1 value is a 5. Our Q3 value, we want to look at the right-hand side this time. So this time we're looking at 9, 10, 11, 12, and 19. So our middle value for that side is 11. So that's our 5-number summary that we found on Friday. Now we want to find the IQR value. And we calculate the IQR value by taking our Q3 value and subtracting our Q1 value. So we're going to have 11 minus the 5 that we found for Q1, and we get 6. So our IQR value is 6, our interquartile range. Now, the next thing that we want to talk about are outliers. And I kind of mentioned this on Friday when we were talking about that extremely large or extremely small values would affect the mean. Well, these extremely large or extremely small values are called outliers. They can make our measures of central tendency look misleading. So we use what's called the upper and lower fence to determine if any outliers exist in our data set. And we use the upper and lower fence by saying if any values are less than the lower fence or greater than the upper fence, the value is considered an outlier. So in example 2, we're actually going to find the upper and lower fence for the set that we were given in example 1. So to find the lower fence, we take our Q1 value. So in this case, our Q1 value was 5. And we're going to subtract 1.5 times our IQR value. And we found our IQR value to be 6.
Where do you get 1.5? Oh,
It's just the given equation that you're multiplying by 1.5.
alright.
So for every problem, we're going to use.
Yep. Yeah, the only numbers that'll change are your Q1 value and your IQR. But you're just plugging those values into that equation.
And you got 6 from the IQR.
Yes, is what we had from from example 1. So you'll just plug this into your calculator, and you should get -4. So our lower fence is -4. So that means if we have any numbers that are less than -4, they would be considered outliers in our set. So to find the upper fence now, we're going to take our Q3 value from example 1, which was 11, and we're going to add 1.5 times our IQR value, which again was 6. So this time we're adding. And we should get 20. So our upper fence is 20. So if we had any values in our data set that were greater than 20, they would be considered outliers. So given our lower and upper fence now, in example 1, in our data set, did we have any outliers?
No.
No, there are no numbers less than -4 or greater than 20. So for that, there are no outliers. Now when you're asked if there are outliers and there aren't any, you can write none, you can write no. Don't write 0, because 0 could be a point in your data set because it represents a number. So just write none, no. You can do a 0 with a line through it because that means the empty set, so that would be acceptable. But don't write 0. So example 3 is putting together everything that we've done Friday and then now today so far. So we need to find the 5-number summary for our data set, find the IQR, we're finding the range of our entire set, we're finding any outliers, and then we're creating the box plot, the box and whisker plot for this data. So again, you want to make sure that your data is organized from smallest number to greatest, which this set already is, but that should be the first thing that you're checking when you look at these problems, is my data set in increasing order? So this one already is, so what's our minimum value? Our smallest value for this set is 11. And then our maximum value, or our largest value, is 30. Now again, your Q1 value is the left hand, or the left side median. So if you need the reminder, it's left. Q2 is your entire set, and Q3 is the right. So it's always So you always want to find your Q2 value first. So we need to find the median of our entire set. And we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 values.
So between both the 14.
So we know that we're going to have to average our two middle numbers because we have an even number in our set. And we end up at these two 14s are our two middle numbers for the entire set. So we're going to have 14 plus 14 divided by 2, which just equals 14. So our median for the entire set, or our Q2 value, is 14. Now, when you're considering your Q1 and your Q3 values, remember our median that we just found is technically in between those two 14s. So when you're looking at the left-hand side, we're going to include this 14 and everything to the left. When we're looking at the right-hand side, we're going to include this 14 and everything to the right. If we had an exact number for our median, you would exclude that median and just look at the left-hand side or the right-hand side. But for this one, these numbers are included in the sides because your median is technically this dotted line in between the two. So for our left-hand side, we need to find our median. And we have 1, 2, 3, 4, 5, 6, 7, 8 numbers. So our middle two numbers that we're going to have to average are this 12 and the 13. So we're going to have 12 plus 13 divided by 2. That's going to give us 12.5. So our Q1 value is 12.5. Our Q3 value, we've got 8 digits or 8 data points. Our middle two numbers are the 17 and the 18. So again, we have to have 17 plus 18 divided by 2. And that's going to give us 17.5. So our Q3 value is 17.5. Now our IQR value. Our IQR value, which we just learned, is our Q3 value minus our Q1 value. So it's going to be 17.5 minus the 12.5. And that's going to give us a value of 5. Our range. This is the range of our entire set. So this is taking our maximum value, 30, and we're subtracting our minimum value of 11. So that gives us a range of 19. Outliers, we'll have to find our lower and upper fences before we can determine if we have any outliers. So we're going to find our lower fence first. So that's taking our Q1 value, which is 12.5, and we're subtracting 1.5 times our IQR value, which we found is 5. And when we punch that in, we get 5. And then our upper fence, our Q3 value is 17.5. And we're going to add 1.5 times our IQR value, which again is 5. So when we punch this into our calculator, we get 25. So our lower fence is 5, our upper fence is 25. So do we have any outliers in our data set?
Yeah, 1.
What's our outlier?
30.
30. 30 is an outlier because it is greater than our upper fence, which was 25. Yes?
So, it doesn't have to be like
25, it can be anything higher than 25.
Yes. Yes, it's an outlier if it's greater than your upper fence. So any number that's greater than 25 is an outlier in this
And
set.
then any number that's lower than like 5.
Yep, would be an outlier in this set.
Can I ask you a question?
Yes.
If it, you know how like the numbers are even, so like,
Mhm.
okay, on the even ones, are there gonna be outliers and the odd ones or not? Or
No, there can be outliers on
on
either.
either? Okay, that's what I was just asking.
Okay, so now that we have all this information, we're gonna draw our box plot. And this number line is a little bit smaller than the ones I gave you on Friday, so we're gonna go by twos. So we're gonna have 10, 12, 14,
That's how we got
and so on until we end up,
it. Which doesn't make sense.
because we have to make sure that we get to 30.
If we did the whole thing, it was in between 14 and 15. So then we divided and when we divided it, it was 14.
So we counted by twos for our box plot, or for our number line this time. So our minimum value was at 11, which is between 10 and 12. Our Q1 value is at 12.5,
Yes.
so that's just a little bit past the 12 here. Our Q2 value is at 14. Our Q3 value is at 17.5, so that's kind of almost to the 18. And then our maximum value was at 30. So remember, at your Q1 value, your Q2 value, and your Q3 value, you have vertical lines to draw your box plot. And then you connect them to make the box. And then you're connecting your smallest value with your Q1, and then your Q3 with your maximum value. So just looking at our box plot, we can kind of tell that 30 was an outlier, since we have such a long distance on our whisker from all of our other information, which seems to be kind of clustered over here. So if you were asked to interpret from the box plot, you could kind of guess that 30 is an outlier. So then the last thing that we're going to talk about today is percentile. And what percentile is it's a number from 0 to 100 that we can associate with a number or a value in our data set. And what it shows is the percent of data that is less than or equal to that point in our data set. So example 4, we're going to actually find some of these and it'll help explain it a little bit better. So for example 4, we want to find the 55th, the 65th, and 95th percentiles for our data set. Now again, you want to make sure that your data set is in order from smallest to greatest, which this set happens to already be in order for us. Now, to find our percentiles, what we want to do is we want to count our total number of data points in our set. In this set, we happen to have 20 data points. So we're going to take our 20 data points, and for the first part, we want to find the 55th percentile. So if we want to find how much is 55% of 20, we're going to multiply by 55%. Now, when you multiply through, you can't multiply 20 by 55. That won't give you 55%.
0.55.
What this actually is it's 20 times 0.55. And that'll give you 55% of 20. So when you multiply this out, you should get 11. Now 11 is not your answer. 11 is not the 55th percentile. What 11 gives you is how many values in your set are at or below for the 55, that's 55% of your set. So you're going to count into your set 11 values, and that given value is your 55th percentile. So we're gonna take, starting at our smallest value, and we're gonna count in 11 values. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 79 is 11 values in. So at that value is where 55% of your data is at or below that value. So 79 is your 55th percentile.
So once you get 11, you just count out 11
Yes.
things?
Yep, so whatever number you get, you're gonna count in, and that gives you your percentile. Because what your percentile is it's actually a point in your data. So 11 doesn't make sense, because that's not in your data.
Mhm.
So you have to actually find a number in your data set.
So how'd you get 20?
Is the total number
Oh,
of points
okay.
that we, of data in our set.
Oh, okay, thank you.
So you'll wanna count up how many things are in your set. This one happens to have 20. So for the 65th percentile, we're gonna take our 20, and now instead of 55%, we're looking for 65%. So we're gonna multiply by 0.65.
You get the number 20 because there's 20 values. right?
Yes.
Okay.
So when we multiply through, we should get 13. So this time we want to count 13 values in. So if 79 was 11, this is 12, 13. So 82 is 13 values in. So 82 is our 65th percentile. And then 95, we're gonna take our 20 and we're gonna multiply now by 0.95. And we get 19. So if we had 20 values in our entire set, 19 values in, should be at 98. So 98 is our 95th percentile. Does anybody have any questions about the percentile or anything else that we covered today? Okay, the last page is your homework, front and back, and we're done.